6.4 cover? Really? What cover? Okay, so which problem is that?
You can pick any that you want.
Okay. I have no idea. Okay, so is this okay?
Sure, that's fine.
Okay, so we have 0 to 5, 7, and 10, and 79.96, 80.21, 80.81, 80.95, and 81.11. Find the regression line and predict the life expectancy of women in 2025, because so 2004 represents T equals 0. So 2025 will represent T equals 21 years. Okay. Oh, I didn't mean to do that. I meant to go directly to the calculator and put the data in and enter and clear. Which part is not clear on this so that I can address it?
I was doing it by hand last night and it kept giving rounding issues, which I figured, hey, I'm doing something dumb and stupid.
But is there a particular problem that you wanted me to work on so we can see what's happening? Or you told me to pick one, so I did.
Oh, not really, no. I was just making rounding issues and I wanted to see how you did it.
Okay. You cannot do this by hand. I don't recommend that, ever.
I learned why yesterday.
But I have the video posted, right? There is a video posted for this. Step by step. Okay. Just in case. Good. So I want to do calculations and I want number 4. And it's this cell 1, this cell 2. I want to use the calculator to enter the information, and then I calculate. So the linear regression line is y hat 0.121465x plus 80.024968. And I have everything already entered. I didn't mean that. I meant this. So the calculator already did that. And now I want second and table, and I will plug in 21 years. So for 21 years, I have 82.58. So for that is y hat 82.58 years. Okay, perfect. Is this okay?
Okay, thank you.
Thank you. Now you have to, if it's Pearson, you always have to look and see how many decimal digits they want, right? So you have to be careful on that. So because if you miss something, they'll consider it wrong. Good, very good question. Next one. Anything? Anyone? Any question you need help with? Anything? Anything you'd like to review? So these were the topics. If you don't have any questions on these topics, then we'll go backwards to test 2. Anyone would like to see any of these topics again? I think I heard a no. Okay, in that case, I want to share my screen and go back to the topics. That's what I was doing. You have all the written homework solutions posted. And I just wanted to go back to test 2 review. Oh, this was test 1. Sorry, I didn't mean to. It's okay. I mean, I can download it and have it downloaded. But, okay. going to look at test 2 and then go back to test 1, although it doesn't matter. Is it still going in circles? Yeah, it's still going in circles. Okay, here it is. Good. I probably had the list on the previous lecture. Yes, it was on the previous lecture. No, I'm not going to do that because it takes too long. Does this happen to you when you go back into Canvas back and forth? Does it happen, or this is happening because of the zoom overlapping with Canvas? Does this happen?
I haven't had any issues with it.
But does it happen like this? It takes a while.
I have a question. We can do if you want.
Yes, of course.
Okay. It's from 5.7. It is y prime is equal to 10y to negative 4, where y is 5 and x is 2.
Okay. So if you'd like to, yeah, so that's where they are. Okay. So if you'd like, you said dy or y prime or?
Y prime is equal to 10y to the negative 4 power. And y is equal to 5 and x is 2.
Good. So we have to write dy over dx, which is 10 divided by y to the 4th. We have to cross multiply. Is this okay so far? Everyone, please. Is this okay? Do you all understand why we went through these steps? It's okay if you say no, and then I will explain again.
Can you explain again, please?
I changed this into this because they are the same. Is that okay?
And then you moved negative 4y to the denominator, or y to the negative 4 to the denominator.
Because that's the exponential rule.
Yeah.
And then I cross multiply. Y to the 4th dy equals 10 dx. Is this okay?
Yes.
Perfect.
Yeah.
Now we need to integrate. The left hand side is y to the 5th over 5. It should be plus c. Instead, we put it on the other side, plus c. We can determine c because we have this point. When x is 2, y is 5. So 5 to the 5th over 5 is 5 to the 4th, which is 625. 10 times 2 is 20, plus c. So c is 605. And I will put it in here. And then multiply both sides by 5. Any questions so far?
No.
Perfect. So then the next step would be, that's my page 3. So I have y to the 5th over 5 equals 10x plus 605. But now I have to multiply everything by 5. So I have y to the 5th equals 50x plus 3025. And now I take the 5th root. So y equals the 5th root of 50x plus 3025. So calculus stops here basically. From here everything is algebra. The only portion of calculus was not this, but just from here, here. This is the only step that has calculus in it. Everything else was algebra. Any questions, please? Anything? Any questions?
No, that was good. Thank you.
Perfect. Let's choose another. Anything else? Anything else? Okay, in that case, let's go back to the previous notes from test 2. So test 2 topics had a lot of exponential and logarithmic functions, graphs, limits, derivatives, equations. It had critical numbers, the study of the first derivative, the study of the second derivative, graphs of rational functions with asymptotes, absolute max min on a closed interval, word problems, related rates, implicit differentiation, and approximations. That's pretty much it. Is there anything that you would like to go back to? Any of these topics for test 2?
Can we do one for the implicit differentiation?
Perfect. Excellent. So implicit differentiation, let me go to the book and let you choose. So implicit differentiation was in chapter 3. I'll find the page number in a minute. Related rates. Implicit. Okay, this is 3.8 and page 359. So I let you choose implicit differentiation from 1 through 33. With a point given, without a point given. Number 21. So let's look at 21. Perfect. Where are you? 21. I see it. So 21 on page 359. So we have 2x to the third y squared equals negative 18, and the given point is negative 1, 3. Did I manage to copy from something else? No. For a change, I copied the right problem. Good. So they're asking us to find dy over dx when x is negative 1 and when y is 3. This is the question. So we differentiate both sides. And here's what we get. This is a product. We put a big dot under the function. X is the independent variable, but y is the function. It's a function of x. Because this is the product rule, I have to use the, if this is a product, I have to use the product rule. First function prime, 6x squared y plus the first function plus times, of course, I have to differentiate this one. But this is a function. I bring down 2, I subtract 1 from the power, and I multiply by the inner function prime, dy over dx. And the right-hand side is nice and easy. That's 0. This is the variable in question. So this has to make its way to the other side, changing its sign. So this piece is 4x to the third y dy over dx, and this goes to the other side as negative 6x squared y. So therefore, we have an expression for dy over dx. The top, so first of all, is negative 6x squared y over 4x cubed y, and we have to simplify it as much as we can. So I'll simplify the y with a y. I'll simplify the 4 by 2 and 6 by 2, and I get 3. I'll simplify 2x, or x to the second power, 2 x's from the top, and 2 x's from the denominator. So the simplified form, it's quite nice, and this is my page 4. So quite nice, dy over dx equals negative 3 over 2x. This is where I plug in x equals negative 1 and y equals 3. There is no y. So I only replace 2x by negative 2, so this is 3/2. So what does this represent? It represents the slope of the tangent line to the graph of y at this point. So the slope is 3/2. Any questions? Was a very good pick.
Can we do number 31 on that same page?
Absolutely. This one, xp cubed equals 24, this one,
Sorry, 32.
this one. Very good.
Yes, ma'am.
So then we have 32. So this is x cubed p squared equals 108. Same idea, and we're asked to find dp over dx. No numbers, just dp over dx. So once they are asking me to find dp over dx, I know that I have to put a dot under p, reminding me that this is a function. So therefore, when I differentiate, I notice that this is the product. I have to use the product rule. So I have 3x squared p squared plus x cubed, the same idea, everything the same, 2p dp over dt equals 0. Again, this piece has to find its way to the other side, and we have to change the sign. 2x cubed p dp over dt equals negative 3x squared p squared. And finally we get dp over dt negative 3x squared p squared over 2x cubed p. I remove a p from the top and 1 from the bottom. I remove 2 of the x's from the top and 2 from the denominator. I cannot continue. This is an equation. So then dp over dt equals negative 3p over 2x. Very good. Good. Good questions. So I'm going to share my screen and go back to the book. No, not go back to the book, go back here. So these were implicit differentiation, examples with implicit differentiation. What are we going